very warm welcome to all the journalists that we have now here in this environment, but also to those that are now listening on ESA Web TV. We are now here today for a briefing on the James Webb Telescope. And I am very happy that I am here now together with a variety of speakers that are helping us to go through this James Webb press meeting. I am here today with Günther Hasinger, ESA Director of Science, Daniel Neuenschwander, Director of Space Transportations, Antonella, Nota, ESA Web Project Scientist, Gillian, Wright, European Principal Investigator for the MIRI instrument, and last but not least, I am here with Thomas Zurbuchen, who is the Associate Administrator for the Science Mission Directorate from NASA. A very, very warm welcome. And let's get started right away with Daniel Neuenschwander, who will explain us in a few words about the expected launch of the James Webb Telescope. Daniel, the floor is yours.
Yes, thank you, Nina, and welcome to this briefing. We are ready to launch the biggest and the most powerful space telescope ever, so welcome to the preparation of the launch of the decade, really. And let me start by underlining that Europe is really here in the first row at the side, of course, of NASA, but also the Canadian Space Agency by having three main contributions. First of all, the Ariane 5 rocket. Number two, by providing the NIRSpec instrument, but also 50% of the MIRI instrument. And last but not least, the European talents. We have a number of astronauts and engineers working on that. So what Ariane 5 is doing, Ariane 5, which is, by the way, a very precise and reliable rocket, is here once again at the service of science and international cooperation. And I really want to insist on that because Ariane 5 has already brought into space a number of key missions. Let me just recall the outstanding Rosetta missions or Herschel Planck, Bepi Colombo, and now we are a few days from before launching Webb. An incredible launch ahead of us. I recall Ariane 5, 780 tons of power to bring up the telescope, which weighs a bit more than 6 tons. So this is really incredible, and we are here to deliver once again in a perfect accuracy in terms of injection. So we have prepared Ariane 5 for this very special customer, and of course, a very special customer deserves also a special treatment. And Ariane 5 has been adapted for the service of Webb. Let me recall 4 points. First, a special cleanliness already on the ground operations on ground. Second, a comfort aspect is very important, and especially in terms of depressurization. We have adapted the venting systems of the fairing in order to ensure that. Third, the thermal stability. We will fly some maneuvers in order to maximize thermal stability for Webb. And last but not least, the introduction of a video system, an onboard video system, which will bring us also a nice picture, and I'm already excited now about seeing them. A few words about the campaign, the launch campaign, where we stand right now. So Webb arrived in October. The campaign really started early November. A key moment was last Saturday on the 11th of December, where Webb was stacked on top of Ariane 5. And you may have heard that previously we have targeted the 22nd of December for the launch. We had an issue, a COM issue to investigate. So our teams are right now working on a COM issue between the observatory and the launch system. It's very important that we take the time necessary to really fully understand what's happening here and to resolve, of course, the issue. And what I can tell you is that the launch will not, take place no earlier than the 24th of December, but we are on a good path of announcing it in a couple of hours. Last but not least, let me conclude by underlining really the partnership between NASA, ESA, and also Arianespace in this launch campaign. It is really based on openness, on transparency, with a very collaborative relationship, and at all stages and at all levels. And I really enjoy this with all the pressure which goes with it. And I think that's a good transition. And over to you, Thomas.
Well, Danny, I'm really glad to continue this. And of course, thank you and also Günther for the extremely good collaboration. It's one of the few times where my original German language, where I grew up with, is actually really useful, because so often our meetings can just go on in German or Swiss German with you, Danny. Also, I'm just really excited for that. We have a long history of collaboration, successful collaboration, and I couldn't be more excited to be here, celebrating this collaboration ahead of this historic launch. Of course, the science topics that we're going to investigate with Webb are manifold. You're going to hear a lot of it later on, but I really want to talk about some of the things that are more nearby. You're looking at images from Mars, from our camera in orbit right now. And of course, actually in the first year, we're going to focus on Mars and look at the composition of the atmosphere, especially also the isotopic composition of deuterium to hydrogen. You say, why does that matter? Well, it tells us about the history and the cosmic origin of that water that is there, and really learning to understand that. So we couldn't be more excited about that. Of course, that goes together with the other assets in orbit around Mars. The next slide talks about another target together with Enceladus. Of course, you're looking at one of the biggest oceans in the entire solar system. Looking at this, that you wouldn't see that right now because it's covered with ice that is cracking and organic deposits. But what our first year investigations will actually focus on is the existence of subsurface reservoirs, and also possible emissions in the near environment around Europe. We're of course excited about this, both on the NASA side and the ESA side, because in just a few years we'll have missions, and the US side Clipper will go there and actually will fly through that environment, and we want to know where these if you want, ejections are that we could be looking at. Again, the origin of life is a big topic, whether it's here in the solar system or elsewhere, looking at exoplanets. So as we go forward, next slide, we're really thinking of an amazing portfolio of missions, at the center of which, of course, is Webb, which is the stuff of dreams of astrophysicists for 2 decades or longer, finally ready, and getting ready to leave this planet. Of course, it will join Hubble, that is up there, TESS, which is out there, the transiting exoplanet survey satellite. I want you to know just an incredible amount of exoplanets are being discovered. 5,000 planet candidates so far, basically a publication each day from this particular mission. And many of them, I believe, will be targets for Webb as we go forward, to really look at their environments in novel ways that we've not seen. Roman is in the mid-decade going up, looking at a larger fraction of the sky and looking at exoplanets, their occultation, but also dark matter, dark energy related topics, which of course are important topics, complementary very much that we're looking at. My final point here before I turn it over is one that is really critical in this, and that is that there are observations, there are exploration that is bigger than one agency, one continent, and it really involves the whole world. And this is one of them. What you're looking at here, this beautiful telescope deployed here, as it was for the last time before being deployed in deep space, is an indication of humanity coming together for a noble cause of really pushing back the boundary that separates what we know from what is unknown. And I just want to tell you that we at NASA believe that our missions are stronger and better when we lock shoulder to shoulder and do the exploration together. So I'm confident, as we're standing here, that this exploration will be, delivering on its promise in so many ways. And I just can't wait for it to leave this planet and start its journey into that. Günther, with that, I'd like to kick it over to you.
Thank you very much, Thomas, for the wonderful collaboration. Can I have the next slide, please? This shows a beautiful Hubble image of the so-called pillars of creation. And the left one, it's optical visual, and on the right one, it's infrared. And so it shows that the infrared can actually look through things which are obscured in the optical. James Webb will actually be 100 times more sensitive than Hubble. So imagine how much more information we will get even from this picture. And this will allow us to look at the first light in the universe, and as we'll also see, habitable extrasolar planets. So next slide shows some of the deepest images from the Hubble Space Telescope on the left side, where months of observing time went in. And on the right side, what we would expect from the deep field of James Webb. And so you see that there are many, many more faint objects. And so we really look much further out in the universe. Now, the next slide shows a zoom in to this deep field. On the top is the Hubble image. And on the lower right, the lower part is the simulated James Webb image. So you see that James Webb will actually have sharper eyes, so it will resolve more information. But then it also, you see all these faint objects, the little dots around this galaxy. And in particular, the red objects are the ones where we really look for the first light in the universe. And so the next slide shows you our current understanding of what we believe we would see. Namely, we have the Big Bang, and there was a hot fireball. And at the first, after 300 million years, the first stars are expected to form. Now, there is a new theory out which assumes that the black holes, which are everywhere, have actually been formed right after the Big Bang, in the first 2 seconds after the Big Bang. And if this is true, then actually the stars, the first stars in the universe, should appear several hundred million years before our current theory. And James Webb will actually be able to decide that. And with this, I would like to hand over now to Antonella for the next step.
Thank you, Günther. So again, I have to repeat again, the James Webb Space Telescope will be the next great observatory in space, designed to answer outstanding questions in all fields of astrophysics. You've already learned about some from Günther and from Thomas. I will cover what else will Webb will do. With 100 times the power of Hubble, the universe will be a completely new view for astronomers. So let's talk about what else Webb will do. Until recently, the only planetary system known was our own solar system. But as Thomas said, we, in the last 2 decades, missions, satellite, and work from the ground discovered thousands of planets around stars nearby. And so Webb will have an opportunity to study this exoplanet and answer the fundamental question that we astronomers ask ourselves, but the public, alike. Are we alone? Is Earth unique? Do we have other planets out there that can host life? Very ambitious questions that speak to all of us. So Webb will study in detail the atmospheres. No, let's go back to the same slide. We'll study in detail the atmosphere of these exoplanets, and we'll look for the key elements like methane, oxygen, water, the building block for life, because there is that ambitious question in all our mind is, are we alone? Is life out there? So Webb will also study all the stages of stellar life. And so as you see in the next slide, you see here from left to right, from birth to death. Throughout this incredible process, stars process and produce heavy elements that then they disperse into the universe in beautiful explosions like the one that you see to the right. And this creates a new generation of stars. And so Webb will answer questions like, how do stars form? How do they evolve? How does the universe get enriched? We have to remember that Webb will be a spectroscopic telescope mostly. Of course, it will take beautiful images, but a lot of the science will be done by spectroscopy. And exactly, so the spectrographs will take the sunlight, the light from any astronomical target, and we split it into their components, like rain droplets split the sunlight into a rainbow after a thunderstorm. Why this is important? Because while images tell you how objects look like, spectra tell you what objects are made of. And this is information that is fundamental for astronomers to do the science that they want to do and understand the physical and chemical properties of this object. So all these ambitious scientific objectives will be reached with a powerful complement of instruments. two of which are contributed by the European Space Agency. The work of spectrograph NIRSpec, which I will say a few words in a minute, and the mid-infrared camera and spectrograph MIRI, my colleague Gillian Wright will say about that in a second, that was originating in a collaboration between the European Consortium in Europe and the University of Arizona. So NIRSpec will be observing 40% of the time during the first cycle. And the beauty of this spectrograph is that is very efficient, can observe 100 targets in the same image. And as you can see here, this is what astronomers expect to see. 100 spectra in one same frame to analyze and figure out what the universe is really made of. And my colleague Gillian Wright will now tell us about MIRI and the science that will be done with it.
Thank you. So a little bit first about the technologies in MIRI, which I think this is typical of all the instruments on Webb, just as the observatory has pushed the boundaries of engineering and development. To match that, we've had to do the same with the instrument developments and develop the techniques to build the powerful spectrometers in Europe that Antonella was just mentioning, the science we can do with spectroscopy. And so these technical innovations built into the instruments are also part of what helps us to do the science. And in the case of MIRI, where we are a partnership between a European consortium and JPL and the University of Arizona in the US, that has brought together our expertise in the optics in Europe with JPL's expertise in mid-infrared detectors and also the cooler. And so you see on my picture here, there are two pictures of smiling people with hardware, and that's the two halves of the MIRI instrument. One half of it is the optical system that does the measuring of the light, but vitally important for MIRI has been the cooler technology development at JPL, because in order to see in the mid-infrared, we have to be 33 degrees colder than the rest of JWST. So this is a really big technical challenge for MIRI that we've had to meet. And to do this, we've done this for the science. By adding the mid-infrared wavelengths to the science that JWST does, we can ask questions in more detail. So when we look at the exoplanets and we want to study their atmospheres, we can see not just water, ices, but also methane, and put together much more knowledge about the chemistry of what's happening in these exoplanets. The long wavelengths of MIRI peer further into the dust where the stars are forming. So when we want to look at the structures of how all this is happening, MIRI will give us a unique view with a sharpness that we've never had in the mid-infrared ever before. And even for the galaxy evolution, if we want to study the hydrogen lines, the strong lines from hydrogen ions that we study in the nearby galaxies, as we look at galaxies that are further and further away, these are redshifted into the mid-infrared. And so MIRI will address science across all of the things that Webb can do that Antonella was talking about. Thank you.
Thank you very much.
Thank you very much, Gillian. And indeed, thanks a lot to Thomas, Antonella, Günther, and Daniel for the introduction. And we can now go right into a Q&A session and take some questions from the participants that are online, from the journalists that are online. I see that there is a question from Irene Klotz from Aviation Week and Space Technology. Irene, we will try to unmute you so you can ask your question yourself. If it doesn't not work, I will read it for you, but let's see if it works. Irene, can you hear us?
I can hear you. Can you hear me?
Yes, very well. Welcome.
Thank you so much. Good afternoon and good morning. I'm not sure who to address this to, but I was wondering what work remains before ESA would be able to confirm the 24th or another launch date, another target launch date. And also if you could please provide some details about the communications issues and steps that have been taken to resolve the problem. Thanks.
Maybe I start and then I hand over to Thomas. Daniel speaking from ESA. So In fact, it's an interface issue in the electrical network connecting the observatory and the ground support equipment. Or to be a bit more precise, it's a cable located in the launch table, which is experiencing some intermittent losses of data. And it is a NASA team who is working right now on assessing this issue, of course, together with the European partners, but under NASA lead. And this is why I would like to hand over to Thomas, but just to underline that the confirmation of H0 or the launch date is a point which is taken together. We have, in fact, a meeting tonight, European time tonight, with Thomas, but also with the other partners from the European side. We need also Ariane, we need also CNES for the launch base. Then we will put all the efforts together and come out with an announcement of what we target as a launch date. Thomas, over to you.
Yeah. So Irene, thanks for the questions. If you look at the spacecraft, kind of final aliveness test needs to be done. That's a test that extends for several hours and basically looks at each one of the systems and establishes its health before we encapsulate the spacecraft. Kind of from that moment on, kind of if you want, it's all rocket stuff. That's on the critical path, right? The encapsulation, and then the testing of the rocket that is there, rolling out and launching, all of it in sequence with the appropriate countdown. So from what of course happened with this interface issue that Daniel described so eloquently, we were delayed in the aliveness test, and that's what really was on the critical path. Our meeting tonight, around 6:00 p.m. Kind of Eastern time, just for you to get a sense. We'll basically look at whether we have managed to do this aliveness test and can go forward with encapsulation. I would say, besides, of course, this is always going to be a special launch. What many people miss is the difference of this launch with anything else. I made a point recently that we had in the last 4 launches at NASA, multiple communication losses like this. And we're going forward and doing it. We're taking more risk. We're not taking any risk with Webb. It's already risky enough the way it is. We're absolutely making sure that everything works. So those are the paths ahead of us. Again, later tonight, we told you all in our statement that we will announce before Friday. We'll stick to that schedule. I just want to tell you, from what I'm looking at, I'm constantly in a text screen. I'm pretty optimistic, but don't take that to the bank yet. We need to get through that test. We need to basically go through making sure that everybody in the team is confident with the announcement of the date that we're marching forward to.
Thank you very much, Thomas. Let's move on with the questions. And the next one is from Alexandra de Castro. Alexandra, you should be able to speak. Your microphone should be working. Can you hear us? Alexandra de Castro from United Academics magazine. Alexandra? I think we heard you. I will read the question for you. So her question is, what is the most challenging part of Webb's journey to its orbit at L2?
Also, I'll start with that. I'm interested what other people will talk about because we all perhaps have our favorite, most complicated. But for me, I would say the biggest challenge on its journey out there is really the deployment. If you think of the deployments, it really is that 5-part sunshield, which is tennis court sized, which is the heart of really the whole architecture of that mission. There's many other parts that need to work as well, but in terms of first or only type of activities that we've never done or really are breaking new ground, this is the thing that stands out in my mind. But I'm interested what others would say.
Maybe I can follow up on that, Thomas. I've always compared this with the pupated butterfly, which is inside its puppet, and then it's breaking off, and then unravels its golden wings, and that's indeed, I think, all of it.
Thank you, Günther. Thank you Thomas. The next question is from Filip, not sure I pronounced that correctly, Ogoczelski from the Polish television science department. Filip, can you hear us? Can you speak?
I think you can hear me now.
We hear you
Please
very well.
confirm.
Welcome.
So maybe start with the question. Do you think that JVST will be more of breakthrough tool for astronomers than the Hubble Space Telescope?
Shall I take this, Thomas, first? Maybe then we can, Antonella and everybody can chime in. When you look at what Hubble was originally made for, to measure the Hubble constant, it did this exceedingly well. The Nobel Prize came out of that and so on. So check mark on that. But actually, when you look at what Hubble discovered was 20 times more, at least, fundamental research. I mean, if you just think about the Oumuamua, the interstellar visitor that came to our solar system and now is accelerating out or so. Nobody dreamed about this topic at all. I mean, so there are completely new science topics. This serendipity is really very powerful, and I believe James Webb will in no way be less exciting and serendipitous. So both Hubble and James Webb will have their part in history.
If I may add, I think exactly, Günther, it's exactly you say, the surprise will be amazing. If we think that when Hubble was launched, we did not know of other planets outside our solar system. And look how the field progressed in 30 years and what amazing discovery Hubble has made. I think James Webb will be much more powerful, but we'll also look at the infrared, which is a completely new regime for astronomers, and that will bring a lot of unexpected discovery coupled with the amazing sensitivity that are totally unexpected.
And Gillian, I think you also wanted to say something.
Yes, so I think of it as a different discovery machine to Hubble. And I think this touches on what Antonella was just mentioning about being able to look in the infrared in this kind of detail. We've never been able to do this before, especially in the mid-infrared. When we've made small missions that have looked with much less detail in the mid-infrared, there's been some pretty amazing discoveries just from that. So I think with Webb, there's a huge potential in the mid-infrared for finding things we haven't even thought about yet.
Thank you very much, Gillian, and thank you, Günther, Thomas. The next question is from Eric Berger. Eric, can you hear us?
I hear you fine. Do you hear me okay?
Yes, definitely. Yes, go ahead.
Thank you so much for doing this. And I'm sorry, I'm going to ask a launch question as well. Just to be clear, I think Thomas said that the meeting to discuss the revised launch date was at 6 o'clock Eastern today. I wanted to confirm that. It's 2300 UTC. That's pretty late in Europe. And then would this meeting be equivalent to like a launch readiness review that's done in the United States that NASA does, or is it just sort of a follow-up to this latest issue to kind of clear it so that you can proceed with the launch campaign? Thank you.
Why don't I get started? I just want to make sure that you understand there's a series of meetings that are going on. Our meeting with Europe is slightly before that. The way I'm thinking about this is kind of the team will go through the aliveness test and basically will give the go for encapsulation. We will then kind of meet with all of our European counterparts, and you correctly noticing that this is really late for our friends there. I think it's another the rate is closer to our time zone than our European friends in Paris or wherever they are. Right? But you see, people are basically coming together to make sure that we give this the best chance. So we're doing basically really clearing the path forward, and basically, after that, if you want, it's much more. Nothing is routine about Webb, but it's a lot more routine after that, because if you want, the spacecraft is now encapsulated, and it's really mostly rocket stuff. So with the tremendous track record that ESA and Ariane Space have, we believe kind of a launch date can be established. Of course, there's other gates that we need to go to. Daniel, why don't you talk about things after that?
Yes, thank you for that. As you rightly said, what we will discuss tonight about is really about to go ahead for the encapsulation. But from this moment onwards, it is more standard approaches, and I think it's very important that we underline here that we will go through the usual passes which we have. I mean, we have encapsulation. Then you mentioned launch readiness review. Just to be clear, we do this also in French Guiana for our launches. We do it for Webb now 3 days before the planned liftoff. That's a standard procedure, and to be very clear, people are committed. People know what to do. They have already a huge pressure. I think what is important is that to just follow now standard approaches from there onwards. Of course, as Webb is a very special payload, we have, let's say, further enhanced some aspects like 4-ICE principle on any critical procedure. That's for sure. But like for any other launch, we stay focused. We know what the mission is, and at the end, we want to minimize the time from rollout to liftoff.
But as far as you're concerned, Eric, later after 6 o'clock, we'll tell you we're working together. You should expect us to communicate what we've learned from that. That's what I hope you got from the exact time, Eric.
Thank you very much, Thomas, Daniel, and thanks for the question, Eric. The next question is from Ivan Fisher from Croatia. Ivan, can you hear us?
Yes, I can. Can you hear me?
Yes, very well. Go ahead.
Okay, I have a question for Gillian and/or Antonella. I'm interested in what kind of complex organic molecules will Webb be able to look for, and will we be able to confirm a hint of perhaps microbial life on new moons of Jupiter, such as Europe or Saturn as Enceladus, and what will the effective range be? Will we be able to find organic molecules on planets around other systems?
You go first, Antonella.
Yeah. So I think that the important thing will be to find oxygen-based molecules, especially when you're talking about exoplanets. Those are the building blocks for life. So Hubble has already shown that we can see water, we can see methane, but oxygen is the building element. So wherever there is oxygen, you can look farther. So molecules that are oxygen-based, I think that will be a primary target search. Gillian, maybe you want to say about specific infrared?
I was going to mention exactly carbon monoxide for just the reasons you discussed. I don't think we will see hints of microbial life. I think what we will do is understand the chemistry better and understand better where and how we should look for hints of microbial life, rather than actually sort of achieving it all in one. This is very careful science you would have to do to be absolutely sure, and so we're taking steps. And yes, the other part of your question was about looking in other systems. Certainly we will be targeting these molecules in some of the exoplanets that we already know of orbiting other stars.
And if I just add a comment to this, of course, just complementing what was already said. If you looked at the Earth and suppose you observed the Earth from the outside as it came together and it started evolving life, one of the things we know is that the atmosphere really changed fundamentally because of life on Earth. So it's that very signature, and in simpler molecules, right? But that very signature that, of course, on life, kind of the Earth atmosphere, the early Earth, proto-Earth, so to say, that atmosphere reflected the emergence of life on the surface that we seek to find. So in that sense, just a very complementary and different approach, but hugely important and impactful approach in kind of biology that we seek to go forward, to complementary to the kind of things that we seek to do when we Mars samples back, for example, or things that are happening in orbit around other, moons, such as Europa. So it's really, if you want, focusing on the same target, but using a different kind of argument towards origin of life, just as important and very, very new. It's really opening up a new door for that analysis.
Maybe can I add my 2 cents as well, Thomas? I learned recently that even the nitrogen in the Earth's atmosphere may well have been produced by bacteria. So that is a developing question, so we are still learning by doing.
Thanks a lot, Günther and Thomas, of course, Antonella, Gillian. The next question is from Stephen Clark from Spaceflight Now. Stephen, can you hear us?
Yes, can you hear me?
Yes, very well. Go ahead.
Hi, thanks for taking my question. Just a couple of follow-ups again on the launch, just so I understand where things are now. Thomas, when I talked to you a couple of days ago, you mentioned the troubleshooting would be initially focused on trying to find the source of the problem with the comm interface, where the issue may be located along that cable path. Has that been discovered? Have you located that? And is it fixed or in the process of being fixed, or are you considering flying, as is, if you understand the problem? And perhaps for Daniel, are there any other issues currently being worked with the launch vehicle system right now that you're also trying to get past to give a go for encapsulation and rollout?
So one of the most important things in our business is to clap at the right time. So it's we believe that the problems have been found. It was actually pretty kind of finicky, kind of very. I mean, it's not an easy. It's not one of those things. Oh, you brought the wrong outlet, right? Not that, right? Kind of these are really tuned up communication kind of interfaces, and frankly, those of us who are in the launch business are aware of these occurring from time to time. It's just when it's web, there are no small problems, so it becomes bigger. So we believe they have found it, but the proof is in the pudding, that the thing needs to go through the aliveness test successfully before we say we're done, which is where the time frame came from, Stephen, that I mentioned before. Over to you, Daniel.
Yes, thanks. In such a campaign of Ariane 5, in each campaign we have a number of topics. I have to say that on top of the topic we had faced mid-November on the clamp end, it is a very smooth campaign, I have to say. There are a few points, but absolutely nothing critical. And I'm really looking forward, and I hope that we can continue the campaign in this sense and have a liftoff as soon as possible. Really nothing critical today.
Thank you very much, Daniel and Thomas. The next question is from Marina Corin from The Atlantic. Marina, can you hear us?
Hi, I can hear you. Can you hear me?
Yes, welcome. Go ahead.
Great. Hi, everyone. This question is for Daniel and Thomas. So as you said, once this communication issue is resolved, you have a few steps to go: encapsulation, dress rehearsal, rollout. Given that this process has already had a few surprises for you already, are you going to approach these new steps any differently? And will the new launch date that you determined today include any extra cushion in case problems come up with these next steps, particularly with encapsulation? Thank you.
Daniel?
Maybe I can start by saying that Webb being a very critical mission, and mentioning just before the clamp end topic we faced a few weeks ago, we have put in place, as I mentioned, a four eyes principle on any critical procedure. I think this is really fundamental to recall here. But on top of that, it is really important that we continue with standard procedures from now onwards, and this is what we are going to do. Nothing is let's say simple on Webb, and this is why we take it very, very serious in all dimensions. But it's important to let the people work according to established procedures, and we are monitoring it up to top management level in all steps. And this is the case also for encapsulation and all the steps which remain to be done.
And if as we go through this meeting this evening, we're going to focus on whether or not we want to include reserve days. I just want you to know that so often at NASA, and I can't speak for Daniel, I don't know how they're doing it. We don't work on launches together very often. But at NASA, we don't put in reserve days, really. We basically try to do all the right things, but basically go success-oriented, because kind of the way you think once a spacecraft sits on top of a rocket, you want to get it off this planet as soon as possible, right? Kind of, but after you do all the checks. So we're going to have this discussion with our friends, with all the partners included. Remember, besides Ariane, spouse, and NISA, there's also CNES. They're in charge of the range. And so there's a lot of individuals that have to work. We, of course, have a lot of empathy for all the individuals from all of our, organizations as we're taking away and impinging on their holiday plans. So that's certainly a discussion we're also having together. Needless to say, many of them are away from their homes. And unfortunately, it seems what happens in my life every once in a while, I'll curse. There's the years that I remember sitting on the lap on Christmas evening. So I know how it feels for sure.
Thank you. Looking at the time, we have, I think, time for another last question. And I would like to give the word again to Alexandra de Castro. Alexandra, can you hear us? Alexandra? Then maybe I can read the question. So the question would be, does James Webb have any artificial intelligence that will make decisions to correct itself on its journey and in its observations? Who would like to take that one?
Maybe I can give it a try also. James Webb will be operated by Space Telescope Science Institute in Baltimore. And I believe there's lots of artificial intelligence in the whole chain of operation, but I don't believe Webb does make their own decision. So maybe Antonella knows better.
No, I will say that the intelligence will be human intelligence. Looking after the telescope, the Mission Operations Center is, as Günther said, at the Space Telescope Science Institute. From there, commands will be uploaded with the observations to be scheduled. And of course, everybody will be watching, making sure that everything proceeds smoothly, but there will be a lot of human, let's say, actions to make sure everything is successful.
Thank you, Antonella. I see that Jonathan Amos has a last question. Jonathan, we would never forget you, of course. Can you hear us?
I hope so. Can you hear me?
Yes, go ahead.
Excellent. Just to be clear, whatever date you choose, let's say it's the 24th, and then we have a minor sensor issue on the rocket, or the winds are not right. You'll come back on the 25th, the 26th, the 27th, the 28th. You will attempt to go right through the holiday period, just to be clear about that, all the way through to I think it's the 6th when the moon gets in the way.
Jonathan, no. And the simple reason for that is whenever you have liquid oxygen rockets, no matter where they are, whether they're in Europe or in the US, out of 3 days, you always need one reset day. So basically, so we're going to put the reset days in there and distribute it. Daniel, anything you wanted to add?
No, that's exactly the point. And we produce, what is also important is that, we produce the oxygen and the hydrogen on spot. And we have the capacity for 3 full fillings, and this we have to take also into account. We just have to decide on one day, as someone said, which allows us to reset the situation out of the lift-off date plus 3 overall. So this is the boundary conditions in which we operate.
Thank you very much. You can see it's getting dark in Europe. I'm nearly in the dark here now over the last hour. I know that there are still some questions out there, and we would be very happy to answer them also. If you can just drop a note to media@esa.int, we'll make sure your questions are getting answered. But we're at the end of our media briefing, and I would like to thank all the speakers again Thomas, Antonella, Gillian, Günther, and Daniel, of course, for being here today. And we're really looking forward to the launch of the James Webb Telescope. Thank you all. Thanks a lot. Take care.
Keep fingers crossed.
Bye-bye.
Thank you very much. Bye-bye.
Bye-bye.